Hey everyone, welcome. Thank you for joining us today. Today we're going to talk about how to deploy a resilient Node.js application on Kubernetes from scratch. The unofficial title of this talk is From npm init to kubectl create. We will go from the basics of containers to deploying a production-ready application on Kubernetes. My name is Kamal Nasser. I'm a developer advocate at DigitalOcean. You can find me on Twitter and GitHub. That's my username there at Kamal7. And a couple of quick notes before we get started. First, this talk will be recorded, and the recording will be shared with everyone registered after the talk and also posted on the DigitalOcean YouTube channel. So don't worry too much about taking notes or screenshots. It'll be available for everyone after the talk. Second, if you do have any questions during the talk, please enter them in the questions box, and we will answer as many of them as we can live at the end of the talk. All right, so I'll start with a very quick outline of what we're going to talk about in the next 30 minutes. So before we can even talk about Kubernetes, we need to talk about containers, more specifically Docker containers. Then we can talk about Kubernetes and how to deploy resilient, performant, and scalable applications on Kubernetes. Okay, I just realized my screen share was paused, so hopefully you can see my slides now. Yeah, so this is the outline of the talk. First, we're going to talk about containers, Kubernetes, and how to deploy resilient, performant, scalable applications on Kubernetes. Now, these are cool words, but what do they mean? It means that the applications we'll be deploying will be suitable to serve 5 users at a time or thousands of users at a time. We'll have multiple copies of our application running at the same time. So if one of them goes down or crashes, for example, our users won't notice downtime because we'll have backup instances running. And we'll also be able to scale our applications up and down, the number of copies up and down as we need to. And not only that, but Kubernetes will always keep an eye on our application, make sure everything is running perfectly. And if our application does go down, Kubernetes will automatically detect it and bring it back to a healthy state for us. Okay, let's get started. So containers, what are they? I like to go with Docker's official definition, which says a container is a standard unit of software that packages up code and all of its dependencies so the application runs quickly and reliably from one computing environment to another. Now, what this means is pretty much you can think of a container as a way to take your application, its source code, along with all of its dependencies and instructions on how to run it, and package all of that up into one single unit called a container. And because a container contains everything that your application needs to run, you can easily upgrade or downgrade to different versions. You can run multiple versions of some dependencies at the same time because each container is completely separate from other containers. And when you create a container, it gets its own file system, its own networking stack, and a bunch of other cool things that makes it isolated and secure by default. So it only has access to what you want it to have access to. Lastly, because because container contains everything that your application needs to run, you can easily have pretty much identical environments in staging, development, and in production. Now, I like to explain things by example. So let's do a quick live demo here. I'll go to my terminal, and I'm in an empty directory on my laptop. There's nothing here. I'm going to quickly create a Node.js application. So first I'll run npm init. This will create an empty Node.js package for me. Then I'll install Express because this will be a web application. And it's only pulling in like 1,000 sub dependencies as usual for Node packages, so it's all right. And now I can create my index.js file. This will be my application. So first I import Express, I import OS, then I create my Express app and define a root at the root that says hi from the system's hostname. Then I set my port to 3000 and listen on it. So this is it. This is my application. It doesn't really do much. This is the application we'll be using throughout this talk. I'll go ahead and save this file and let's try it out. Let's run it. So node index.js, listening port 3000. I'll go to my browser. I'm at localhost 3000, reload, and there we go, hi from my laptop's hostname. So application works. This is pretty much it. So I'll close it now, and let's take a look at what it will take for us to package this application into a container. So the first step in creating a container is creating the Docker file. Now, a Docker file is a file named Dockerfile, and it contains instructions on how to build the container image. So I'll create my Docker file here, open it in my editor, and like I said before, a container gets its own file system when it runs. So right now, the container we're building has a completely empty file system. And we don't want to start from a completely empty environment. We want to have at least an operating system and Node.js pre-installed, because that would just make things easier for us. So one of the cool things about the Docker ecosystem is there's this huge library of community-built images that we can tap into. And just like with Node.js, there is NPM, which is probably the most widely used package registry. With Docker, there's Docker Hub, which is the most widely used Docker registry for container images. And one of the images on there is the node image, and that's what we'll use as a base for our container. So I can do is type from node. This will tell Docker to use this image as a base for this container. Then we'll go with version 13 for Node.js 13, and I'll also say -alpine. Now, if I were to just do node 13, that would also work. But what the -alpine part does is it uses a version of the node image that is based on the Alpine Linux distribution. Alpine is a very minimal Linux distribution. It really only contains the very minimal things you need in an operating system. So it's very small, and by opting to use it, we can keep our resulting container images small and fast to build. So now that we have a base here with Node.js pre-installed, we can start copying our application into our container. So first I'll set my working directory. This can be anything I want. I like to go with /app, and I can start copying my application into the container. So I'll copy my package JSON and package lock JSON files into the container. Then with those files in there, I can install my dependencies. So I run npm install, pass it -- production to optimize for a production environment. And with the dependencies taken care of, I can copy the rest of my application over into the container. So I can say copy ... This will copy everything in the current directory into the container. It will copy my index.js file and everything else that I have in my directory to the container. Now that we've got everything in there, we just need to set the port that our app will listen on, and that's 3000. So I can say expose 3000. Now, this doesn't actually go and do anything. It's only there for documentation. But it's really good practice when writing container images so that people who do use your image know what to expect. Finally, we just need to set the command that is run when the container is started, and that will be node index.js. So this is it. This is our Docker file. This is how we will build our application. Now, when Docker starts building this image, it will read this Docker file, look at each line, and execute it line by line in order. So first start with the base image, and it'll copy things in order that we specified. So I'll save the Docker file, and now we can go ahead and build our application, our container. And to do that, we will run docker build. And by default, when you build a container image, it gets a hash as its ID. It's kind of like a random string. It's not entirely random. It's based on the contents, but it looks like a random string. It's not very convenient to use. So what we can do is choose to tag it with an additional name. So I'll say -t and tag it with the name Kamalin7 node hello app. Now I just need to give it the path to the current directory. And once I run it, it will start building the image. You will see it executing the Docker file step by step. So we've got step 1 from step 2 working directory and so forth until we get our image built. So this is the hash, the image ID that I mentioned, and this is the other tag that we chose to use for the image. Now, if I scroll back up, you will see that in step 1, you'll get a hash. Step 2, you also get a hash. Step 3, and so forth. So this is what's happening here is that this is a result of the way Docker built its images. So instead of building an image as one single unit that has everything, what Docker does instead is for each line in the Docker file, that line gets its own layer. And all the changes that this line makes get recorded separately from the other lines. And so the resulting image is basically a composition of all those layers applied on top of each other. And this is actually a really cool thing, because if I go back into my terminal, open my index.js file, and go to the hi here and change it from hi to hello. So I've made the one-line change to my index.js file, save it. And now if I try to build my image again, you will see that for the first few steps, it says using cache. So up until step 4, for each one, it says using cache, and only when it gets to step 5 does it stop saying that. So what's happening here is that Docker has detected that we've already built an image just a few seconds ago, and the only change right now that we've made from that older image is to the index.js file. So it's smart enough to know that this is the only change that was made. So only when it gets to the step where the index.js file is brought into the container, and that's step 5 where we copy everything into the container, up until then, nothing has changed. So for the first few layers before that, it can just use the exact same layers of the older image and then build on top of them the new image with the changes that we've made. So this is a really smart way that um, Docker helps you keep your image builds efficient and also fast. Okay, so now we've built a few images. Let's run them. Let's try them out. Now to run our image, we will run docker run, and we'll give it a few options. So by default, when you run a Docker container, if it's stopped, Docker saves it for you, so you can restart it back up again if you want. But because this is just for testing, I wouldn't need it anymore once it's stopped. So what I can do is pass --rm. This will tell Docker to delete the container once it's stopped. I'll also pass -d, which will run the container in the background because I'll want to use my terminal while it's running. And this is where we actually expose the port. So I'll say -p, and then map port 3000 on my laptop to port 3000 inside of the container. Finally, I just need to give it my image name, and that's Kamalin7 Node.hello app. And once I run this, I get this ID back. And this is actually the ID of the container that we just created. So if I run docker ps, this will print the currently running containers on my laptop. You will see this container we just made. This is the short version of its ID. It's just the first few characters of its full ID. And you'll also see a few other details about it. Okay, so our container is running, and our application should be available on port 3000. Let's try it out. Go back to my browser, reload, and just like that, you see a response back from the container. You'll notice that the hi was changed to hello, and instead of my laptop's hostname, you will see the container's hostname. It's actually the container's ID. So just like that, we took our application, we packaged it into a container, and now we're accessing it through the container running on my laptop. Now, that's pretty cool, but it's only available on my laptop, right? If I wanted to run this elsewhere or share it with others, I need to push it to a registry first. So I will push my container image to Docker Hub now, and to do that, I will run docker push, and then just give it the image name, and you will see it pushing the image also layer by layer. So you will see that for some of them, it says layer already exists, right? So another cool thing about this whole layering mechanism is that it also helps you keep your image uploads efficient, because we built our image on top of the Node 13 image from Docker Hub, right? And the layers of that image are already exist on the registry. That's where we got them from. So Docker is also smart enough to know that those layers already exist on the registry. We don't have to upload them. So it can just reuse those layers from the registry and only upload the new layers that we just built. Okay, so now the push is finished, and anyone in the world can take my image name and run a container and get the exact same thing that I just got on my laptop. It's exactly identical. That's pretty cool. Okay, so this pretty much concludes the Docker part of this talk. If you have any questions, please type them in the questions box in the GoToWebinar software, and we'll answer them at the end of the talk. But with this done, we can move on to the second part of the talk, and that's Kubernetes. You might be asking, what is Kubernetes? Why should I be even excited about it? So Kubernetes is a container orchestration system, right? And a very simplified version of what that means is it lets you deploy and manage your containers in a declarative way. So there are two types of deployments. There's a declarative deployment style and an imperative deployment style. And there's just one main difference between them. And let's forget for a second about Kubernetes and imagine that we wanted to take the container we just built and push it to production. So what you could do is go to your DigitalOcean account, create a new droplet, install Docker on it, run the container, map your domain name to it, and you'd have your application running. If the application crashes, you'd have to manually go in there and fix it. So that's an imperative deployment style where you want to achieve something. So you go and tell the computer step by step how to get there. Now, on the other hand, a declarative deployment style, what Kubernetes lets me do is it lets you, instead of outlining the exact steps that you need to do in order to achieve the result that you want, instead you will just describe the resulting state that you want. So for example, I want to run this container and I want my domain name mapped to it. And that's it. That's all you have to do. You take that description, send it to Kubernetes, and Kubernetes would go on its own, figure out the exact steps that it needs to do in order to get there, and do them for you. And not only that, it will also keep an eye on everything for you. So if something goes wrong, it will automatically detect it and bring it back to health state for you. So you don't have to manually go in there and fix it. So I have a Kubernetes cluster running on my DigitalOcean account. And you might have seen this meme that says, there is no cloud, it's just someone else's computer. And I mean, it's funny, it's true, but there is no such thing as a magic cloud, right? It's all actual servers running in data centers at the end. There's just some layers of abstractions on top of that. But one really cool thing about Kubernetes is that even though it is built of actual servers, it it lets you think of your cloud infrastructure less as individual units, but more of a just a generic pool or cloud of resources. So there is some sort of cloud after all. And a Kubernetes cluster is built of a couple types of servers, of nodes. First, you've got the master node, and that's pretty much the brains of the system. It makes all of the decisions for you, and it's responsible for taking care of everything pretty much. And the second type is worker nodes, and these are the actual nodes that your containers will be run on, and usually you'd have a multiple of them in your cluster. So in my DigitalOcean Kubernetes cluster, I have 3 worker nodes. You can see them here. And the master node, which you don't see here, is actually handled by DigitalOcean for me. I don't have to worry about it. And the main way you would interact with the Kubernetes cluster is using the kubectl command line tool. And going back to declarative deployment, the way you would describe your resulting states is by using these YAML manifests that pretty much describe what components you want to have and how you want them to behave. And then you would go and send those descriptions to Kubernetes using the kubectl apply. Now, if you've used Kubernetes before, you'll be very much familiar with this command and this style of deployment, but we're not going to do that today. What we're going to do instead of writing these YAML manifests, because I mean, writing YAML is boring and no one really wants to watch that being done live. What we're going to do instead is build our deployment piece by piece, also using kubectl. Now, I do want to highlight that in a production environment, you would not do this. You would go and write those YAML manifests and apply them to your cluster. That's the correct way to do it. But this is just a demo, and I think doing it interactively is a good way to see what each component does and how all those different components work together. So it's time for another live demo. I'll go back to my terminal. And one thing about Kubernetes is everything in Kubernetes is represented as a resource. So kind of like an API resource. And using kubectl, you can create, edit, delete, patch, and do all those operations on those resources. So one example of a resource in Kubernetes is the node resource. And these are the worker nodes that you saw in the screenshot before. So let's try running kubectl get node. This will get all of the resources of the type node in my cluster. And you will see the 3 worker nodes that you saw in the screenshot before. Okay, so kubectl is working, it's connected to my cluster. Let's get our container running on Kubernetes. So what I can do is run kubectl create deployment, and then I need to give it the image name of my Docker image. That's command 7 node hello app. And I also need to give it a name for this deployment, so I'll just go with node-app. Now once I run this, I'll see deployment node app created. This means this was successful. So right now I should have my container running inside my Kubernetes cluster using this container image we just built. And another thing about Kubernetes is that the very basic smallest building block is not a container, but what's called a pod. Now, just to keep things very simple and easy to understand, I'd like you to think of a pod as a container, just a fancy word that Kubernetes uses for a container. It's not exactly a container. There are some differences, but just to avoid any confusion, you can think of a pod as a container. So what we can do is take a look at the pods in my cluster, and you will see that we do have a pod running named node app and some random characters. And this is actually running the container we just made. You can see it was created 44 seconds ago. So our container is now, our application is now running in Kubernetes. Now by default, when you create a pod in Kubernetes, if it crashes or if it goes down or anything, it will not be started back up again. But what we have here is a little different. So when we ran kubectl create deployment, we didn't actually create this pod. What we created was a resource of the type deployment named node app. So if I run kubectl get all, this will get the most common types of resources in my cluster. You will see that we have the pod here that we saw previously, but we also have two other resources. We've got what's called the deployment. This is the node app name that we chose. You can see it here. And we also have a replica set, which is another type of Kubernetes resource. So when we ran kubectl create deployment, what we actually did was create this resource. We didn't create the pod, we didn't create the replica set. The deployment itself created the replica set and pod. So a deployment in Kubernetes is a high-level Kubernetes resource type that manages pods for you. And you can think of a replica set as another type of Kubernetes resource that helps the deployment do its job. So because we have this deployment here taking care of my pod, if it goes down, if it crashes, the deployment will create a new pod to take its place. And we can see that in action. So if I run watch kubectl get pods, this will run kubectl get pods every 2 seconds and print the output in my terminal. And I'll split my terminal here. So I've got a terminal at the top and one at the bottom. And if I type here kubectl delete pod, and then take this pod name and paste it in, so kind of like simulating a crash. So if you keep an eye on the terminal at the top, once I delete the pod, you will see it being terminated, and instantly a new pod is being created to take its place. And this is the deployment doing this job. And one other thing we can do is run kubectl scale deployment, then give it the deployment's name, node app, and I'll say replicas 3. So right now we have one copy of our pod running, right? Once I run this command, I can scale it up to 3 copies. So this will instruct the deployment to keep at all times 3 copies of the pod running. So I run it, it says scaled. If you look up, you will see 2 new pods being created, so that alongside the older pod, we have 3 pods running, 3 copies of our application running at the same time. And just like before, if something happens to one of those pods, a new one will be created to take its place so that we're always at 3 pods running. Okay, so we have all these copies of our application running on our cluster. Let's access it. Let's try it out. Well, not so fast. We can't access our application right now. The reason is it's only accessible from within my Kubernetes cluster, right? I can't access it from my laptop, which is outside of the cluster. So in order to be able to access the application, the deployment, what we can do is expose it just like we did with Docker. So I'll run kubectl expose deployment, then give it the deployment name, and there are a few ways to expose a deployment. The first being the type cluster IP. This will expose it on a private internal IP address inside of the cluster, but that's also not accessible from my laptop, so I don't want that. The second type is node port. This will expose it on a random port on the worker nodes, but it's also publicly accessible. So that's what we're gonna use. And I just need to give it the port that is the port that my application is listing on inside of the pod, inside of the cluster, and that's 3000. So once I run this, service node app exposed. So what this actually did was create a new resource of the type service for us. So if we look at the services in our cluster, kubectl get service, you will see that we have one with the name node app, the type is node port, and you also see the random port that was assigned to it. So our application is now actually accessible on this port. So we can go ahead and try that out now. What I will do is get my worker nodes again, kubectl get node, but this time I will pass -o wide. So this will instruct the kubectl command to print even more details about my worker nodes. And one of the new columns that you see here is the external IP column. And these are the public IP addresses of my worker nodes. So I'll grab one of them, and I will use the curl command to simulate a browser request. This will send an actual HTTP request. This is just like browsing to it with using my browser, but I can do it without leaving my terminal. And I'll paste in the IP address, take the random port, paste it in, and I get a response back from our pod. Hello from Node app, the name of the pod. So just like that, we took the Node Docker image that we just built, we deployed it on our Kubernetes cluster, and we can communicate with it. That's pretty cool. But it's not good enough for production. It's okay for testing or development, but a couple of reasons is that first, I'm using an IP address and port, and in a production environment, you'd have your domain name mapped to it, and using just DNS, there isn't an easy way to map an IP address and port to a domain name, right? It has to be like port 80 or 443 for HTTP, HTTPS. And the other thing is that remember when I talk about Kubernetes letting us think of our cloud infrastructure less as individual units, but more as just an generic available cloud of resources. We're using the IP address of one of the worker nodes here directly. So that kind of goes against the cloud of resources thing, because if this worker node goes down, if it stops responding for any reason and it needs to be replaced, our application would go down alongside it, because we're using the IP address directly, and if that stops working, our application will stop working. So what we can do here is use a different type of service to expose our application. So one other cool feature of kubectl is it lets you edit resources in place. So I can run kubectl edit service node app, and once I run this, kubectl will get the YAML manifest that is backing our service that is running right now in the cluster and open it in my text editor. So this is the actual YAML config for the service that is running right now. And I'll scroll down to the type and change it from node port, the type that we use, to the third type, load balancer. You'll also go up to the port here and change it from 3000 to 80. Target port will remain set to 3000. This is the port that is being used inside of the container, and that hasn't changed. So this will stay set to 3000. Now, once I save this file, kubectl will look at those changes I just made. It will validate them and send them back to my cluster. So now my service got those changes applied to it. So if I get the services again, you will see the same node app service is now of the type load balancer, and its external IP address is pending, whereas previously it was none. It didn't have an external IP address. And what's happening here is that behind the scenes, Kubernetes is creating a native DigitalOcean load balancer for me, and it's attaching it to this service. So if I go to my browser here, go to my DigitalOcean control panel, you'll see this new load balancer being created. And once it loads, you will see the worker nodes being attached to it. These are the worker nodes in my cluster. And this is automatically handled for me. If I create new worker nodes, or if I replace any one of them, those changes will be made to the load balancer too. Now, while it's being created, this is actually, it's kind of cool, like the way this works. it's not actually Kubernetes that's creating the load balancer for me, but instead it's a different program running inside of my cluster that created the load balancer. So when DigitalOcean provisioned this managed Kubernetes cluster for me, they installed on it what's called a Cloud Controller Manager. The Cloud Controller Manager is a type of program commonly used in Kubernetes clusters that watches for a few special types of resources, like services with the type load balancer, and it handles them on behalf of Kubernetes. And the reason this is kind of cool is that if I go ahead and do everything we've done here, all these commands in Kubernetes manifest, if I would go and do all of this on a Kubernetes cluster on, say, Google Cloud, for example, without making any changes, I would have gotten a native GCP Google Cloud load balancer instead of a DO one, because it's handled by the Cloud Controller Manager, and it's a really cool cloud agnostic way to handle provider specific resources. So now our load balancer is created. I will get my service again. You'll see that it has an external IP address now. This is a public IP address, and this is where my application is now available. So if I curl it again, and this time I don't need to specify a port because we set it to 80, I get a response back from one of the pods. And this time it's going through the load balancer first. So instead of going directly to a worker node to a pod, it goes through the load balancer, which then forwards it to any one of the worker nodes. So if I run it a couple of times, you'll see that each time I run it, I get a different pod name, right? These are the host names of the pods. So I get a different one here, here, and here. And this is the load balancer doing this job, right? Like its name implies, it's balancing all of this incoming traffic load, all of these incoming requests across all of my worker nodes, across all of my pods. And another thing is that this load balancer will also monitor my worker nodes for me. So if one of them stops responding, it becomes unhealthy. The load balancer will be smart enough to stop forwarding requests to it, so our users won't see any downtime. And if one of the pods goes down, it will also not forward any requests to it. So it's kind of like a couple of layers of protection against user or client visible downtime. Okay, so got our application running and our load balancer handling all the incoming traffic for us. So just to quickly sum up, what we've done is we took our Node.js application, we packaged it into a Docker container using the node image from Docker Hub. We then built the image and pushed it to Docker Hub, so now it's accessible to everyone. And within my Kubernetes cluster, first we created a deployment that ran one copy of my pod, and then we scaled that up to 3 copies. And then we created a load balancer that takes all of the incoming traffic from the internet and balances it across all of my different copies of my application running. So now I can take my domain name, map it to this load balancer, probably post it on Hacker News, Reddit, and all those social platforms, and I can know for sure that my application will be able to handle all of this incoming traffic. So we can also scale the application up to multiple replicas if we get more traffic than we expected. So let's say our application goes viral, we can scale it up to, I don't know, like 7 replicas, depending on what our application needs. And then once the traffic calms down, we can scale it back down to 1 replica because it's not getting as much traffic as before. So this is also a cool thing about Kubernetes is that it lets you maximize the efficiency of how you use your cloud resources. Okay, so this is it. I hope this was helpful. Thank you for tuning in and for listening. The link here goes to a page with the slides that I've used for this talk, and also all the code and different commands that we used. There's also a $100 DigitalOcean credit enclosed in that link. So if you don't have a DigitalOcean account and you want to try out Kubernetes, you can sign up using the link in there and get a free trial with $100 credit to try out everything you learned about Kubernetes and Docker for free. And the QR code in the top right corner is that same link. All right, let's look at questions. Okay,
All right, thanks for the presentation, Kamal.
Thanks,
To the
Samantha.
audience, thank you for joining us. I'm Samantha from the community team at DigitalOcean. I'll be moderating the question and answer portion. Like Kamal said, we'll answer as many questions as we can live, and if your question is one that we don't get to today, we'll answer it later and share that with you via email along with the video recording. So first question, Kamal, can you describe shortly how is your terminal connecting to your DigitalOcean tools, like Kubernetes, for example?
Okay, should unmute myself. Yes, so the question is how is my terminal connected to my DigitalOcean Kubernetes cluster? The answer is the way kubectl connects to my cluster is when you first create a cluster in DigitalOcean, let's go to my cluster here. You will be able to download a config file, and this is the config file with all the authentication details that the kubectl command needs in order to connect to the cluster. There's also another way to do this using the doctl command line tool. This is the DigitalOcean API command line API client. The other way to do it is by running doctl Kubernetes cluster. I think it's save config. So it takes care of configuring kubectl for you and entering all of the authentication bits that are needed to connect to the cluster.
Great. Does DO provide a private Docker registry service, or do we need to set that up ourselves?
Yes, this is actually a great question because this is something that we've recently launched. DigitalOcean Container Registry is now available in early access to everyone. You can use it to create your own private Docker container registry. So for example, you see I have my own registry here. It gets this URL. It's completely private, and you can use it within your Kubernetes cluster and also just regular Docker containers.
Awesome. What is a good use case for cluster IP service?
A good use case for cluster IP service. If you have a private, so if you have, I guess if you have a microservice based architecture, not necessarily. If you have a private program running that accepts any kind of connections from other applications, let's say you have a database running and you want your Node.js application to connect to it, instead of using, you would need to create a cluster IP service to connect to it through your application running inside of Kubernetes, but it won't be accessible outside of the cluster. So a cluster IP service is for connecting private deployments inside of the cluster, and the other two, node port and cluster IP, node port and load balancer, are for publicly accessible services.
What kind of DigitalOcean account would you recommend for setting up a Kubernetes cluster? How much does it cost? At a minimum, how many cores and RAM will I need?
Okay, a Kubernetes cluster, first, the master node is completely taken care of by DigitalOcean for you, so you don't pay for it. When you create a Kubernetes cluster, it uses the worker nodes use the exact same plans as regular droplets. So going to the create page here, I can set up my worker nodes. The very minimum is one worker node, but you'll see this notice here that if you want to prevent downtime during upgrades or maintenance, you have to have multiple nodes running. But the very minimum is one node at the smallest plan of $10 a month. And that comes with 2 gigabytes of memory, 1 virtual CPU, just like a regular droplet would.
Cool. Should load balancers also be scaled? What if they go down?
Yes, load balancers are highly available by default. A load balancer created by DigitalOcean has multiple copies, multiple instances running. It's managed by DigitalOcean for you, but it's highly available. Everything is maintenance or bringing it back up if it crashes is automatically handled for you. So it's scaled by default, pretty much.
Does Docker push match the container tag to the Docker Hub tag and upload there automatically? What if the tags don't match?
Yes. So when I ran docker push here, the tag that was used is latest. This is the default tag that is used when you don't specify a tag. So if I push this again, if I build a new image using this exact same image name and tag, and then push it on Docker Hub, it will overwrite the existing image. So this is how you would basically upgrade or push new versions. If it doesn't exist, if I push a new tag, let's say, I don't know, version 1.0.0, it will be created on Docker Hub. So it's synced with the tag names that you push using the Docker command.
Which layer of the Docker build process is read-only? What are the security issues related with the data in the host, which is mapped to the data directory in the container?
Okay, so there are two questions here. What's read-only and what is... so first, what's read-only? So nothing is really read-only in the container. From the point of view of the application running inside of the container, it has access to everything. Just like any Linux operating system, you can run a different user and change the ownership permissions to restrict that. But it will only have access to its own file system. It will have zero access to the file system of the host that is running the Docker container. Now you can mount, for example, if you want to mount a directory, share a directory between the host and the running container, you can mount a volume which will share access between the container and the host system. So it can overwrite files in there. But when you do configure the volume, there's an option of setting it as read only. So the Docker container will only be able to read the files, but not write to them.
In the demo, you chose to scale your application manually to 3 replicas. Is it hard to make the up and down scaling automatic?
That's a good question. I scaled it manually, but you can definitely configure it to be automatically scaled. There's what's called horizontal Kubernetes scaling, auto scaling, which will monitor the CPU, maybe memory usage, probably other metrics that you can choose to monitor. And if it notices that the load is getting high and the application is no longer able to handle all of the incoming traffic, it will automatically scale it up to the maximum that you set and the minimum that you set, depending on the traffic. So that's called horizontal Kubernetes scaling.
What kind of customization does DigitalOcean offer for a Kubernetes cluster?
What kind of customization? So you can choose different versions. Obviously, you can create different worker nodes, worker pools. So if you want to have like 3, let's say standard nodes, then you can create another pool with CPU optimized nodes with, I guess, dedicated CPU cores for very heavy workloads. And you can specify what deployments go on which worker pools. So you can customize cluster in that way. Other than that, there isn't really much that you can customize with your cluster. You can, I'm just looking at like the settings page. You can set automatic upgrades and set the timing there, but anything else is just the standard Kubernetes cluster behavior. If you have any specific questions, I'd be happy to answer that.
Cool. You created 3 nodes and 3 pods. When you created the pods, did Kubernetes deploy them over the 3 nodes or only over one?
This is a good question. It should deploy them on different nodes. You can look for sure. So if you get the pod, you can describe this pod. So get the pod's name, describe it. In here, you'll see which of the nodes it was deployed on. Yeah, I can't find it right now, but you will be able to see which of the nodes it was deployed on. By default, I believe it should distribute them across all the worker nodes.
What about the secret key and DB password? Do we have to upload this to a packaged Docker Hub repository?
No, uploading secrets is never something that you should do on your Docker images. you can, if you use environment variables, you set them when you run the container. So when you run the deployment, actually I'm not gonna edit it right now. When you run the deployment, you can set any environment variables. Kubernetes also has a resource of the type secret that can contain secrets. You can mount those secrets either as environment variables on the containers or mount them in as files in a directory. But they should always be outside of your Docker images.
Why should I use Kubernetes instead of building Docker containers for deployment?
It really depends on your use cases. Personally, for personal projects, I just use Docker. I don't use Kubernetes. For very highly trafficked websites, very important production environments, the benefits that Kubernetes provides you is all of the automatic health checking that we've just seen, all the like cloud native integrations with load balancers and everything. So it really depends on what kind of workload you're expecting, what kind of environment, what resources you have to manage that environment. Both are completely valid. It just depends on your use case.
Great. When you scale database containers, will each one contain different data?
Um, if you it depends on how the database is deployed. If you deploy it like a normal container, using the container's file system, they will have different data. You can mount, just like with Docker, if you mount a directory inside the container containing the database data, you can also do the same on Kubernetes using a volume. Um, most database uh, software actually use their own copies of the data and periodically sync the different copies so that they're all up to date, but they would have their own underlying storage.
Does it change the process if you have nodes in different server locations, such as SFO or NYC?
Right now, a Kubernetes cluster can only be deployed in one region. You can't create multiple nodes in multiple data centers. What you can do is create multiple Kubernetes clusters, but that's a bit complicated and really outside of the scope of this talk because it makes things a bit more complicated.
In a situation where a containerized application needs to access a file system or database that is common to all instances, how does Kubernetes help here if each pod has its own version of the file system?
Okay. If you need to share something across multiple nodes, that you can either copy it into the Docker image, but in case of databases, that's not a good idea. You can mount a volume on multiple nodes, but by default on DigitalOcean Kubernetes clusters, a block storage volume can be mounted only on one pod at the same time. Some of the options you have here is running a network file share like NFS and other file share systems. There is a cool Kubernetes project called Rook, rook.io, I believe. It basically spins up a Ceph block storage cluster inside of Kubernetes for you. So you can use it to mount the same thing the same volume on multiple pods, but it's too much for just like a simple file. That's really good for like heavy production environments.
What's the best practice to get logging from the Kubernetes nodes?
Okay, you have multiple options here again. You can either take the logs from the containers outputs themselves and then send those to an external service. You can do that. So remember when I said a pod is kind of like a container? So a pod is basically a wrapper around the container. A pod can be one container or it can be multiple containers. But if you have multiple containers in one pod, it would be um, represented as a single unit by Kubernetes. So what you can do is run your application like we did now and save all of the logs to a file on the file system. And what you can also do is run another container inside the same pod that will watch those logs and ship them to an external logging service. So these are two options to shipping logs directly from the pods. The other option that you have is listening for the Docker engine's logs on each worker node. So outside of zooming out a bit outside of the pod, just have one program running per worker node, ingesting all those Docker logs and then shipping them to an external service.
How do we sync data between load balanced nodes?
Um, it really depends on what kind of data you're talking about. You would usually use an external database, like if you have a MySQL database, for example, it will be external to the pods themselves. So you wouldn't like it would handle sharing the data for you. If you're talking about files, you can like share the volumes, like we've mentioned before. But it really depends on what kind of data you need to share.
Does Kubernetes take care of rolling deployments? If yes, is it automatic?
Yes, it takes care of rolling deployments for you. So the deployment we have right now is takes care of the process for you. When you push a new version of the container image, by default, it will use a rolling upgrade. We use a rolling upgrade to push this new version. So first, it will create the new pods and then gradually delete the older pods. This is customizable, but by default, it is enabled.
Does creating a load balancer service in Kubernetes also create a load balancer service on DigitalOcean?
Yes. Yeah, exactly. It creates a load balancer service in DigitalOcean and links them together. And one important thing to note about this, though, is that when you create such a service, be sure to not make any changes to the underlying load balancer yourself, but instead make those changes to the service. Because when you make the changes to the service, they will be applied and pushed to the load balancer. But if you modify the load balancer directly, those changes will be reset because the Kubernetes will periodically make sure that the service matches the load balancer matches the service. So always edit the service itself and not the load balancer directly.
Would we be able to use Helm to install custom packages for the cluster?
Yes, definitely.
Great. Let's see, there are a lot more questions here. I'm trying to read through the ones that we have time to get to today. All right. If using microservices and a database cluster, how does Kubernetes handle the transaction of data? Do you create multiple database pods with a single master, or every new Node.js pod connects just to one master instance?
Assuming the database is also running on Kubernetes, you would just like we said before, you would create a cluster IP service that would map to the database itself, and all Node.js pods would connect to that same service. So usually you'd have one master node in a database, and you would connect to it directly. But it's running a database inside of Kubernetes is a little complicated. It's definitely doable, but the recommendation is to use an external managed database because it just makes things very much simpler.
Can I manage application deployment or versioning using Kubernetes or DigitalOcean, or should it be done by an external service like GitLab? If an external tool is needed, do you have an integration with GitLab?
Okay, assuming I understood the question correctly, it's more about how to get the new versions pushed to the cluster. You can definitely do it however you like. It can be part of your CI/CD workflow. You can, just like we did with kubectl on my laptop, you can connect as the last step in your CD continuous development workflow, you would run all the necessary kubectl command to update the image version and push it to the cluster. So you can do that automatically, or you can do that manually yourself if you wanted to. I know GitLab integrates with Kubernetes. I haven't used that feature actually, so I don't know how it works or like how that works. So I can't say for sure.
Is it possible to create UDP load balancer or a TLS load balancer using DigitalOcean's Kubernetes service?
Yes. So when you create a Kubernetes resource, one of the fields on that resource, any Kubernetes resource, you can attach annotations to it. And the Cloud Controller Manager, the program that creates the load balancer, also looks at those annotations for you. So you can specify, if I go to my load balancer, this is a load balancer we just created, you'll see that it uses a TCP protocol by default, but you can add in an annotation to the load balancer service that says, hey, change this to HTTPS or HTTP2. And you can also select the certificate also using annotations. This is all documented in the DigitalOcean Cloud Controller repo. You can find it here. We've got all the documentation here and how to actually apply those annotations and configure your load balancer. I've got some examples too.
Is there a way to see how much load a pool is currently undergoing? Can this be done with an HTTP call?
Sorry, can you repeat that again, please?
Yeah, is there a way to see how much load a pool is currently undergoing? And can this be done with an HTTP call?
I mean, it's possible in a way. I don't remember for sure if it's part of the default Kubernetes services, but there are a couple of services that you can install that monitor the nodes for you and expose metrics on HTTP endpoints. There's kubestate metrics, is a very popular one. Yeah, there are programs that you can run to expose metrics for you. I don't remember for sure if it's part of the default services.
Thanks. Does the load balancer support MQTT?
What's that again?
MQTT. I don't quite know it. It's a lightweight messaging protocol.
I am not familiar with that, but it does support these protocols. So if it's part of those, then it does work.
Cool. Well, we have 3 minutes left and quite a few more questions, so we may not have time for everything. Kamal, there are a few people who asked about demonstrating auto-scaling. Do you have time to do a quick demo before we hop off?
That would have been very, very awesome to see live, but 3 minutes is definitely not enough time to set that up. You would have to. There are quite a few steps to achieving that, so unfortunately, I won't be able to demonstrate that live.
No worries. All right. Well, thank you so much, everybody, for your wonderful questions. I know that there are more questions out there, especially ones that involve longer demos. We'll try to answer them as best we can via a Q&A doc and then send that to you over email. If we don't get to it, we're going to send out a survey right after this when the webinar closes. Just tell us what more you'd like to learn about next, and we'll be happy to produce more of these tech talks for you. Thank you so much for joining. Thank you, Kamal. We hope to see you again soon.
Awesome. Thank you, everyone.